The next group of data types we'll cover are numeric types. And of course, we've already seen one. We've been using int all over the place. It stores whole numbers. And we've been using the plain, regular variety of int, but recall from the docs that there's integer and int. Those are the same. It's just a shorter version it's a short way of referencing integer. They mean the same thing, but there's also small int, tiny int, medium int, and big int. So I don't want to dive too much into the details, but it's actually quite simple. The difference comes down to how large of an integer you can store with each type. It's all about optimizing storage and how much memory things take up. So a regular integer, or int, the one we've been using, takes up 4 bytes, according to this table. And the maximum signed value, remember we talked about the signed versus unsigned. Signed means it could be negative or positive, is this number here, which is what? 1,000, 100,000. All right, so is which is 2 billion. It's hard without the commas, but I think it's 2,147,483,647. Okay. That is the maximum signed value. So the minimum would then be this negative 2.1 billion. And then if we compare that to some of these other integers, like TINYINT can go from negative 128 up to 127. So if we were storing something small, like the number of children somebody has, or the number of dependents on their tax returns, or something horrible like that, tiny, there's no reason to have this much space allotted, which would be 4 bytes. Why not just stick to 1 byte and have a small integer, or technically a tiny int? I can show that really quickly. I'll do it over here. It's not going to look any different to us really, but I'll create a table. Let's call it parent. And then we just have children, which will be a tiny int. And if I insert into parent, we don't have any other information about a parent, just the number of children they have. That's fine. We can do, 2. Or somebody else has about 7 children. That's quite a few. Or 0 children. That works great. But if I try and insert something much larger, 200 children, we get an error, out of range value for that column. So if there is any possibility somebody could have more than 128 children, or 127, then fine. Maybe we use small int or medium int. This is all just about optimizing storage and the amount of space that each one of these values takes to store. So int is a default. That's all we've been using. You can store quite large numbers. There's big int, which stores way larger numbers, but takes up double the space. And then there's medium, small, and tiny. So if you really care and you're trying to be, trying to optimize storage, which is a good thing to do, I just feel like it's overkill when you're starting out, but it's good to know about. And if you're in a situation where you do care about it, then you can take a look at this table or go to the docs and find the appropriate sized integer. The last thing we'll talk about with ints is the signed versus unsigned. So by default, we're working with signed integers. When we say, data type is int or tiny int, I can go from negative 128 up to 127. So technically, I could have a negative number of children in here, negative 3. Maybe I don't want that. So what I can do is say that we're only working with unsigned. Now, we're also going to learn how to add constraints, checks to say that a number has to be greater than something or between something. So this is not the only way or the main way that you would go about enforcing a positive number of children. But it is a way of saying every tiny int in this table is going to be positive because it is a signed integer versus unsigned. So it looks like this. When we create our table, let me drop this table, parent, recreate it, and instead of simply saying children is of type tiny int, I say tiny int unsigned. And it's going to look exactly the same. If I try and insert a new child or a new parent in there with 3 children, it works. But if I try and do negative 3, we're now out of range because we specified this has to be an unsigned tiny int, which just means there's no negative sign. And that allows us to store a higher possible max, right? 255, but the minimum is now 0. So you can use unsigned as the keyword with any of these others. You could do int unsigned, big int unsigned. That's enough about integers. I usually just stick with int unless I know for sure I'm dealing with something small.